Okay, today we are talking about one of the most audacious projects in human history, the race to harness fusion energy. We're talking about capturing the power of the sun, the literal engine of the stars, and building a miniature version right here on Earth. It sounds like science fiction, but it's getting closer to reality every single day.
And look, the stakes here are just immense. This quote from Carmichael Roberts really nails it. This isn't just about a new way to keep the lights on. We're talking about a milestone that could completely transform human civilization with clean, limitless energy. It could change everything. So, what is this incredible dream that we've been chasing for so long? Well, put simply, it's about figuring out how the sun works and then building our own little version of it. At its core, nuclear fusion is actually a pretty simple idea. You take two really light atoms, say types of hydrogen, and you smash them together with so much force that they fuse. They become one heavier atom, like helium. And when that happens, bam, a massive amount of energy is released. You can almost think of it like two atoms giving each other a cosmic high five that literally creates light and heat. It is the universe's ultimate power source. Now, you might be thinking, wait, isn't this just like the nuclear power we already have? And that's a great question, but the answer is a big no. Traditional nuclear power, or fission, works by splitting heavy atoms apart. Fusion does the exact opposite. It combines light ones. Its fuel is basically seawater, so it's super abundant. It doesn't produce any of that nasty, long-lived radioactive waste. And get this, the process is inherently safe. There's zero risk of a meltdown. It is, for all intents and purposes, the perfect energy source.
All right, so if it's so perfect, what's the catch? Why don't we have fusion power plants lighting up our cities right now? Well, that's because, for decades, we've been slammed up against a few absolutely massive challenges. First up, the heat. To get this whole fusion thing started, you need to create temperatures of around 150 million Kelvin. Let me put that in perspective for you. That is 10 times hotter than the core of our sun. Yeah, so the first giant hurdle has been figuring out how to contain something that mind-bogglingly hot without it instantly vaporizing your entire machine. And that insane heat leads us to the main scientific villain of our story for a long time, something called the plasma density limit. See, in these donut-shaped reactors called tokamaks, your superheated fuel's in a state called plasma. For years and years, scientists had this problem. If they tried to pack more fuel in to get more power, increase the density, the plasma would just freak out. It would become unstable, and the whole reaction would just shut down. It was like trying to blow up a balloon. You can only put so much air in before it just pop. Because of these hurdles, commercial fusion always felt like it was 30 years away. It was a running joke. But then, just in the last few years, the story completely changed. We hit a massive turning point.
The breakthroughs came fast and furious. In 2021, boom, MIT and a company called CFS create these powerful new magnets that allow for way smaller, more efficient reactors. A year later, boom, Lawrence Livermore Lab achieves ignition, the holy grail. For the first time, they got more energy out than they put in. And then, just recently, scientists in China cracked that pesky plasma density limit, finding a whole new, stable way to run the reactor. All of a sudden, the game was on.
And these breakthroughs weren't just wins in a lab notebook. Oh no. They fired the starting pistol on a global race, sparking this incredible explosion of investment and competition to see who can be the first to actually sell fusion energy.
And to give you a sense of just how seismic this shift has been, listen to this from Nuno Loureiro at MIT. He said that if you'd walked into a room of fusion scientists just a few years ago and told them that venture capitalists were about to pour $9 billion into their field, you would have been literally laughed out of the room. Today, that's exactly what's happening. The numbers are just staggering. A whole new fusion economy is popping up. A single private company, Commonwealth Fusion Systems, has raised almost $3 billion. And governments are going all in, with the UK dropping £2.5 billion and Germany €2 billion. This is not a small-time science experiment anymore. And this right here is the key takeaway. This is the single most important shift. For the first time ever, the big questions aren't about the science anymore. We've moved from, can we do it, to, okay, how do we build it? It's not a physics problem anymore, it's an engineering problem. So, with the science basically solved and the money pouring in, where does this high-stakes race go from here? Well, the road ahead is incredibly ambitious, but for the first time, it's also clear. Companies like CFS have laid out a seriously aggressive game plan. They're aiming to show net energy gain in a commercial-scale machine by 2027. At the same time, they'll be designing their first actual power plant with the goal of connecting it to the grid in the early 2030s. That's potentially just a decade from now.
And what's driving this incredible rush? Well, the potential payoff is world-changing. An MIT report projects that by the end of the century, fusion could supply a huge chunk of all global electricity, maybe even up to half. It would be a total game-changer for getting off fossil fuels.
And you better believe the world is ready and waiting. People in the industry say the demand is already through the roof. Think about all the new data centers for AI that need massive, constant, clean power. If fusion plants existed today, you could sell as many as you could build.
So that brings us to the final big question. For more than half a century, fusion has been that beautiful dream, the energy of the future that was always just over the horizon. But now, with the scientific walls tumbling down and billions of dollars fueling the race, you have to wonder, after all this time, is the future finally here?